Let's see how this circuit works. Our first transmitter was a single transistor-based oscillatory circuit. It oscillates according to the push button being pressed. Instead of the push button here, we use a NPN transistor to turn on the oscillator. Also use a 555 IC-based tone generator to turn on the transistor Q2 at a particular frequency. There are two switches in the tone generator circuit. The IC produces 250 Hz while pressing the switch on and 650 Hz while pressing switch 2. While pressing the switch 1, the IC will produce a frequency of 250 Hz on its output pin 3, and that pulse reaches the base of the transistor Q2 through the 330 ohm resistor. That pulse will turn the transistor on and off 250 times. When the transistor turns on and off 250 times, the oscillator circuit connected to it also turns on 250 times. Due to this, the transmitter produces pulsating 27 MHz radiation. The same thing will happen while pressing switch 2, but the pulsating frequency will be in 650 Hz. Let's see what will happen in the receiver circuit while receiving a pulsating 27 MHz signal. The working of the front-end section of the receiver has already been explained in the previous video, so not explaining again. The pulsating signal from the transmitter causes a sudden current flow on the transistor, which makes voltage fluctuation on the collector pin. The comparator circuit convert voltage variation into a square pulse waveform, and we get the exact pulsating signal frequency from the comparator output pin. The output of the comparator is connected to RX3E frequency decoder IC. When the decoder IC detects a frequency of 250 Hz on its input, it makes the fourth pin high and the connected first LED will light up. When it detects a frequency of 650 Hz, it makes the fifth pin high and the connected second LED will light up. Making of the oscillator circuit already explained in the previous video. Adding the tone generator circuit. Transistor Q2 for switching the oscillator circuit. 555 IC-based tone generator section. The output pin 3 is connected to the base of transistor Q2 through 330 ohm resistor. Let's check the waveform of each section. Waveform of switch 1. Waveform of switch 2. Modulated waveform of 250 Hz. Modulated waveform of 650 Hz. Comparator circuit. Making of comparator circuit already shown in previous video. Adding the frequency decoder circuit. The output from the comparator is connected to the input of the frequency decoder through 100 ohm resistor and the capacitor. RF receiver front-end section, making as explained in the previous video. Connect the front-end section output to the comparator input pin, and connect the positive and negative wires. Connect batteries. Waveform of comparator output. The comparator output gives the exact 250 Hz while pressing the switch 1. The comparator output gives the exact 650 Hz while pressing the switch 2. Let's check the working. Red LED lights up when switch 1 is pressed. Yellow LED lights up when switch 2 is pressed. I checked the transmitter range and the receiver is able to catch the signal up to a distance of about 10 meters.